In this video, we're going to talk about how to solve systems of linear equations using matrices. But before we do that, we want to talk about what is called reduced row echelon form, or REF. Now, it's very similar to row echelon form, except every column containing a leading 1 has a 0 in every position above and below the leading 1. So examples of reduced row echelon form. Notice, in each column you have 1s and then 0s everywhere else. So if we're dealing in terms of x's and y's, we know x is -3 and y is equal to -7. For our other example, notice here, 1, 0s everywhere else. 1, 0s everywhere else. The 1 where it belongs, and 0s everywhere else. So in terms of x, y, and z, I know my solution is 2 and -3 and 9. All right, to solve systems of equations using Gauss-Jordan elimination. 1, we're going to write the system of linear equations as an augmented matrix. Use row operations to rewrite the augmented matrix in reduced row echelon form. And we're going to write the matrix as a system of linear equations from step 2. The result is the solution of the system. So let's solve the system of linear equations using Gauss-Jordan elimination. Now, let me show you what I would expect this to look like. 1s where they belong, 0s here, and the answer column here doesn't matter. All right, so let's write this out as an augmented matrix first. Okay, so this one is here, but I need to get rid of this one here. So using row 1, I'll take the opposite of row 1 plus row 2 is going to be my new row 2. Okay? All right, so easy to write, -1 plus 1, -1 plus 2, and -10 plus 14. So write my new matrix. So again, row 1 stays the same, and change row 2. Now, this one is where it belongs, so this is the one I need to get rid of. So what am I going to do? I'm going to take the opposite of row 2, I'll add it to row 1, and that's going to be my new row 1. Okay? So let's do this. So 0 plus 1, -1 plus 1, and then -4 plus 10, which is 6. So below, I will write this. Okay? So row 1, and then row 2 does not change. So we know x is 6, and we know y is equal to 4. So my solution here is going to be 6, 4. And again, very easy to check. Check both of the original equations. 6 plus 4 is 10. 2 times 4 is 8. 6 plus 8 is 14. So this is a solution to the system. Okay, so now let's take a look at an example of a 3 by 3. Now, remember what reduced row echelon form is going to look like. I'm going to put this up here. Okay, 1s where they belong, 0s everywhere else here, and then the answer column, I really don't care what that looks like. So first off, I'm going to write out the augmented matrix. Okay, the 1 is where it belongs, but this one needs to go. So I'm going to use row 1, and I'm going to take the opposite of row 1 plus row 3 is the new row 3. Okay, so doing the row operation, we end up getting for row 3, 0, -1, -2, and -2. So I have placed them into row 3 as such here. Okay? All right, so the first column is done, and I've got the 1 where it belongs here. But this one needs to be a 0, and this -1 needs to be a 0. So I'm going to use row 2 for both. So what am I going to do? I'm going to take the opposite of row 2 and add it to row 1. That's going to be my new row 1. And I'm going to take what? I'm going to take just R3 plus R2 is going to be my new row 3. So doing the row operations for this -R2 plus R1, that gives me 1, 0, 2, and 7. So there's my new first row. So R3 plus R2, 0 plus 0 is 0. 1 plus -1 is 0. Negative 1 plus negative 2 is negative 3, and negative 4 plus negative 2 is negative 6. So now what I need to do is to take this negative 3 and change that to a 1. Well, how can I do that? I'm going to take what? Negative 1/3 R3 and convert it to the new R3. So I'm going to take every single element in row 3 and multiply by negative 1/3. So we've done that here. Okay. Now, the 1 is where it belongs. This needs to be a 0, and this needs to be a 0. So I'm going to use row 3. So I'm going to take what? Row 3 plus row 2 is my new row 2. And I'm going to take negative 2R3 plus R1 is going to be my new R1. So doing the row operation for row 1, I get 1, 0, 0, 3. And again, R3 plus R2, very easy to do. 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. And negative 4 plus 2 is negative 2. So now it is in RREF. So now my solution for this is 3, negative 2, and 2. So again, very, very easy to check and to verify that that is going to be the ordered triplet for this. Okay, one other example I want to take a look at then. Now again, I will draw a picture of what I would expect this to look like at the end. Okay, make sure the ones are where they belong. Zeros above and below, and then this column, it does not matter. So the first thing I would like to do is to write the augmented matrix for this. Okay, so the 1 is where it belongs, but this 3 needs to be a 0, and this 2 needs to be a 0. So I'm going to use row 1. So I'm going to take negative 3R1 plus R2 is going to be my new row 2, and I'm going to take negative 2R1 plus R3 is going to be my new row 3. All right, so we've done the row operations, so our new row 2 is going to be 0, 4, 2, 2, which we've put here, and the new row 3 is 0, 0, 5, 7. Okay? So column 1 is completely done. So now this 4 needs to be a 1. So what I'm going to do is I'm going to take 1/4 of row 2 and make that be my new row 2. So the new row operation is showed as such with the new values here. So I've got the 1. This now needs to be a 0. So what am I going to do? Using row 2, I'm going to take row 2 and add it to row 1, which is going to be my new row 1. And so this has been shown as such. 0 plus 1 is 1. 1 plus a negative 1 is 0. 1/2 plus negative 1 is negative 1/2. And 1/2 plus a negative 2 is negative 3/2. So now the second column is done. So now let's go to the third column then. Okay. This 5 here needs to be a 1. So what am I going to do? I'm going to multiply the third row by 1/5. Okay. So let's put that underneath. Okay, so now we've got 2 more things we need to do. This 1/2 and this negative 1/2 has to be a 0. So again, you're going to use row 3. I'm going to take negative 1/2 R3 and add it to R2 to give me my new R2. And I'm going to take 1/2 row 3 and add it to row 1 to give me the new R1. So doing the row operations, we end up getting this new matrix. So now this is finally in RREF. So now I know what my solution is going to be. So let's write it as an ordered triplet. So that's negative 4/5. That is negative 1/5 and 7/5. Again, you can check that quickly to determine that that is a solution to all 3 equations in the original system. Okay. When you take your exam for this unit, you get the choice of using either Gauss-Jordan elimination, which is what I've done here, or Gaussian elimination with back substitution, which is what I talked about in a previous video. The choice will be yours.